introduce our presenter. Mike Walker is the founder of Beacon Consultants Network, Inc., a marketing consulting firm specializing in strategies for large-scale human behavior change, and is a recognized expert on marketing energy efficiency programs and on IT energy efficiency measures. On behalf of electric utilities, Energy Star, NYSERDA, and EEA, and EDF, and others, Mike has helped hundreds of organizations make the business case for IT energy efficiency and implement changes to save energy, reduce operating costs, and prevent pollution. Mike also teaches a graduate business administration course on marketing. He graduated from the University of Virginia and holds a master in public administration from Harvard's Kennedy School. So Mike, thank you so very, very much. I know that I've been definitely looking forward to this because I am a non-techie. So thank you, and I believe you can take it away.
All right, well, thank you, Lynn. Thanks for the invitation. We will just jump right in here, and I've asked Lynn to interrupt me liberally if we have questions or points of clarification. So please do use the question and chat window to fire off some questions. Just a couple quick details on who we are, because it can be a source of confusion. So Beacon Consultants actually works on behalf of the Energy Star program, which is funded by the EPA. And we're known as technical support contractors. How did we get mixed up in this mess? Well, we have just the right experience. So our expertise, as Lynn mentioned, is large-scale behavior change. Our clients ask us things like, how do we get people to care about energy efficiency or recycle or immunize their kids or wear seatbelts or whatnot? Well, we have an extensive background in IT management, so it was kind of a perfect fit. And we've actually been advising Energy Star for more than 10 years now on the intersection of information technology and energy efficiency. We are by contract vendor neutral. So you're going to hear me mention some solutions and some software and possibly some products by name. We're not endorsing anything. We can't do that. This is ultimately a taxpayer-funded program, so we're not allowed to pick winners. The good news in that for you is that you really get as much as there is such a thing as an unbiased take. You'll get it. And last but not least, we get paid by EPA. I'm going to mention a lot of free services today. They are exactly that. They're free. We don't have a hidden agenda here. Quite frankly, I get measured by EPA on how much energy I help organizations like yours save. So you're probably used to thinking of EPA and specifically Energy Star when you think of refrigerators or AC units. You've probably seen the little blue logo, but there's actually quite a history with EPA and IT energy efficiency, and I won't bore you with the details beyond saying that we helped develop the first software system that helps IT managers centrally manage PC power. We work directly with the Microsoft development team to improve energy efficiency in Windows 7 and Windows Vista. We've developed Energy Star ratings for a whole host of products. Servers, PCs, copiers, printers, as you know, and then some things you probably don't know. Data centers can get the Energy Star rating. UPS systems, we'll get into what a UPS system is later. It stands for uninterruptible power supplies, but you can get an Energy Star rated UPS system, and then we'll have more data storage and data cooling equipment added to our product mix shortly. And we have assisted directly literally hundreds of organizations, large and small, government and corporate, when it comes to saving energy in IT. So why are we here today? There's a big opportunity. And you may be wondering, why is this opportunity still being discussed? And we've been talking about this opportunity for 10 years, specifically, ways to save energy with computers and data centers and so forth. Here's why, in a nutshell, these savings really are still untapped. One is the incentives in most large organizations just don't line up in a way that facilitates action. And so to put a finer point on it, what I mean is, generally speaking, when we work with an organization on IT energy efficiency, we're often introducing the IT manager or the data center manager to the person that pays the energy bill for the first time. They never met. The IT department goes about its business making decisions about the equipment to purchase and how to operate that equipment. And in some other building, some other side of the corporation, through a completely different reporting structure, is the poor soul that pays the actual utility bill or bills. And one of the things that we have to get past is the fact that those incentives aren't lined up for action. Second, a lot of IT professionals just haven't had to think about energy efficiency. It's not in their training. So there is a certain amount of technical expertise when it comes to energy efficiency in IT that just isn't general knowledge. So we've been doing this for a while, and we've figured out how to get you past these barriers, and that's what I'm going to share with you today. I'm going to give you a preview now of some of the free resources, because some people may have to leave early or whatnot, but I'm going to go through the various opportunities that exist for savings in IT energy, in IT energy efficiency, but you know, at the end of the presentation, I'll get into a little bit more detail some of these free resources that are available to you. So we do vendor-neutral technical consultations for saving energy, whether it's network computers, data centers, miscellaneous plug load, and IT. We have software that we can give you for free for managing. CPM stands for Computer Power Management. We can help you with savings estimates to build the business case for action. We can even help you with power metering studies if you want to document before and after energy consumption. And last but not least, public recognition. One of the big arrows in our quiver, if you will, is to publicly recognize companies on behalf of Energy Star for saving energy, helping to promote cleaner air. So let's start with a little mental game. If you will, get an image in your mind of all the computers in your organization. And if you're a school or a university and you run a computer lab, it might look something like this, or maybe a sea of cubicles. And I want you to imagine for a minute each of those workstations or computers turning into two $20 bills. And now I want you to imagine walking around and collecting those stacks of 20s. If you're like me, sometimes your PC feels like it's worth about two $20 bills. We have those days. But you can imagine if you're in a large organization, accumulating a nice stack of 20s, and then I just want you to imagine pouring those or pushing those down the nearest drain. So a little bit of hyperbole here, but my point is this is actually happening in, we believe, about 70 to 75% of organizations in the U.S. right now. And what do I mean? Well, they aren't power managing network computers. They aren't taking advantage of sleep settings that are built into those PCs. As a result, those PCs are on when they don't need to be. And on average, that wastes about two $20 bills or $40 per year. So that's the first opportunity I'm going to talk to you about today with IT energy savings. And I'm going to spend a little bit more time on it because it is by far the largest opportunity for most organizations. We're going to talk, that may be a surprise because a lot of people say, well, data centers, they use a ton of energy. Why isn't that number one on the list? And the reason is very few organizations actually operate data centers anymore. You have to be at a certain scale before you're going to operate a data center. And a lot of us, particularly smaller, medium-sized organizations, simply outsource that now to a cloud provider or a co-lo facility or any other number of arrangements. So the biggest opportunity for most of us is power managing network computers. I'm also going to talk about how to specify Energy Star for a range of office equipment purchases. I'm going to talk about a few tricks for managing power consumed by peripherals around the computer and just miscellaneous plug load that you'll find in a typical commercial building. And I will touch on data centers. I'll tell you that it's a meaty topic, and I do an hour-long webinar that's basically Data Center Energy Efficiency 101. And I'll talk to Lynn, and if there's interest in that, I'd be happy to do a second webinar on that. But we're just going to graze the surface and give you an appreciation for what opportunities might be there. So let's start with power managing computers. So what is computer power management, and why should I care? I mentioned before, these are features that are on every computer. They automatically put the computer, when it's inactive, into a low power mode. And you just simply shake the mouse or hit the keyboard to wake up the computer. As I mentioned, they're built into Windows, Mac, Linux. They go by different names. It depends on the operating system that you use. You may have heard of Standby or Hibernate or Sleep. They essentially do the same thing, and we can split some hairs later and get into the details about the difference among those specific names for computer sleep. But the thing you need to remember is that these settings have to be activated on computers that aren't purchased at retail. So what do I mean by that? If you go out to Staples or Best Buy and buy a new computer, chances are good that Microsoft will have defaulted these sleep settings on in that computer. But that's not the way most organizations get machines. Most organizations buy directly from Dell or directly from HP or IBM or what have you, or they go through a third-party value-added reseller or vendor. And in those cases, for a variety of kind of interesting but not worth getting into reasons, those settings aren't activated, so they are going to have to be activated. If you don't activate these settings, you're essentially leaving all the lights on in your office. And I don't think anybody on this call would leave their office looking like this each night. In effect, you may be doing that if you aren't taking advantage of these computer sleep settings. I'm going to use Windows XP just because a lot of people are familiar with it, and I'm just going to try to take a little bit of the mystery out of computer sleep settings. So if you went into a computer that has Windows XP installed on it and you opened up the control panel, this may look familiar to a lot of you. If it's a laptop, you'll see these two power settings right here, plugged in and running on batteries. And so computer power management is simply making sure that you're taking advantage of these bottom two settings in Windows XP, and that you set the computer to, in this case, enter system standby after 20 minutes when it's plugged in, or hibernate rather after an hour. So that's all we're talking about. And the challenge is, well, we'll get into the challenges in a minute. But that's what we're trying to do. In addition to the energy savings I mentioned, there's some other good reasons to do this. I mentioned $40 on average. We rarely see an organization save less than $10 per computer. Occasionally we'll see an organization save more than $100 per computer per year. So that alone is enough of a reason to do this. But if you're in a climate where you do a lot of cooling, southern U.S., western U.S., there's more savings for you because you reduce cooling loads. The reason for that is active PCs and computers give off a lot of waste heat. When they're inactive or in sleep mode, they don't. So you have an opportunity to potentially reduce demand charges with computer power management settings, and ultimately you're reducing the load on the electrical grid, which decreases air pollution, reduces your carbon footprint. And I like to mention this, even though there probably aren't a lot of federal facilities on the call today, but the federal government actually requires agencies to activate these sleep features. So let's pause for a second and just put computer sleep settings into the larger context of an energy footprint of a commercial building. So what you see in the small pie chart on the right is the total energy footprint of a typical office building, and it's mostly HVAC, which stands for heating, ventilation, and air conditioning, and lighting. But then office equipment and miscellaneous business equipment is a big chunk, almost a third of the building. So what this shows you is doing computer power management. And then, if you look at what makes up that office equipment slice of the pie, it's mostly computers and monitors and some other business equipment. The point I'm trying to drive home here with some data is, even if you don't think computer power management is a major contributor to your energy footprint, you may be wrong about that. And in a lot of instances, we will do computer power management and nothing else for a commercial office space and reduce the entire footprint of that building by 10 to 20%. So even at the scale of a facility, it's a big deal. A lot of you may already be doing monitor power management, which means the monitor goes into a low power sleep mode. You'd know this if it just goes blank after a period of time. It can be a little difficult to distinguish whether that's going on and computer power management is going on. They're two different settings. Monitor power management is a very easy thing to do. There are no complications essentially with it, but it's something you want to make sure you're doing, and we'll talk more about that in a second. Computer power management is really our goal today. It's a little more challenging and it delivers a little more savings. As you see in this illustration here on the right, the first opportunity to say, or pardon me, the first setting is dim the display. That's basically monitor power management. And then put the computer to sleep at the bottom is computer power management, which also makes the monitor go into sleep mode. So a few words on computer power management. It substantially drops the power draw. It still wakes up in a few seconds touching the mouse or keyboard. Saves, as I mentioned, $10 to $40 on average. It can save quite a bit more than that if you don't already use monitor sleep. And in the Windows 7 Power Options dialog box, it looks like this. So I've thrown a lot of information at you about computer power management, monitor power management. What's the bottom line? Well, EPA recommends that you set your display or monitor to enter sleep after 5 to 20 minutes of inactivity, and you set the computer to enter standby or hibernate after half an hour or 60 minutes. There are a couple other settings in there. Turn off hard disks, don't worry about it, doesn't save much energy. But obviously the lower the setting that you select, the more energy you'll save. So in this way, you use both monitor and computer sleep in tandem to save the most energy and still deliver a good experience for your users. So why hasn't everybody under the sun done this already? That is a good question. There's two challenges from a purely IT administration perspective. One is you don't want to actually have to walk around to all these computers and make these changes by hand. You could do that. There's a lot of good reasons not to, and it's just labor intensive. So first challenge, managing this centrally. Second challenge, you are probably aware that your Windows, and this is true with Mac as well, computer has periodic security patches that it downloads and installs, and there's antivirus definitions that can get updated as many as a couple of times a day. You may run backups. All of these things get complicated slightly if your computer's in sleep mode. So this is it. These are the two problems that we have to contend with, and the good news is there are a ton of solutions out there, including administrative tools that you may already own, and free software that you can download from Energy Star. If there's some financially minded folks in the audience, let's just make quick work of this. Computer power management offers a really compelling return on investment when viewed as a project. You might have to spend money on software, probably not. Worst case scenario, $15. Then we list labor costs. Well, what is that? Well, you'll need to spend a little bit of time finding the best solution for your particular IT environment that meets those two challenges I just talked about. And you may have a couple of exceptions, computers that don't play nice with the new regime, and you'll have to troubleshoot those. We help organizations with this all the time, so they aren't big deals. But it does take a little bit of staff time. So worst case scenario, you're looking at $15 plus $5, $20 a cost versus energy savings, again, on average $40 per year, multiplied by 3 to 4 years, which is the average useful life of a computer, and you're at $120 to $160 per computer or seat. That's how we refer to it in the IT world. So $20 investment for max for a very nice, $120, $160 return. So some of you may be scratching your head and wondering, well, why don't we make this simple, Mike, and just ask people to turn off their computer each night when they go home? And then we don't have to worry about computer sleep settings and the potential complications you mentioned. Well, this is a pretty compelling thought, but in fact, you won't save any more energy by doing that. And here's why. We've talked with dozens and dozens of IT managers, probably hundreds, and we found that even in organizations where they require people to turn off their computers at night, they don't get full compliance. So that's point one. Point two is you don't really save much in terms of electricity by turning off the computer. So in other words, the delta between off and sleep mode is typically a watt or two, which just isn't even going to register over the long term on your energy bill. So the net is, if you forget to shut down your computer manually a couple of times a year, you're going to negate anything you would have gained from having it off. So it is definitely in your interest to have these sleep settings enabled so they automatically sleep. A quick case study for you, West Hartford Public Schools, here's an organization that had not power managed the monitors for the PCs, and they were doing something which is all too common, and that is they were asking people to leave their computers on after work. That sounds a little crazy. It is kind of a little crazy, but a few years ago there was a kind of an IT administration mythology out there that you wanted computers on after hours, so if you needed to run some diagnostics on them, you could reach them through the network. No longer necessary. That is, and hasn't been best practices for probably 5 to 10 years. But it's still very common out there. So what was the solution? They used a free software tool from Energy Star. It's called EasyGPO. It's probably been used by thousands of organizations. It gave them control over all the sleep settings on their networks, on the network computers, and the results are 3,000 computers in the school district going into sleep mode after 40 minutes, and the monitors go to sleep mode after 30 minutes. And they're seeing a savings of around $64 per computer per year. So for a school district, that's big money. So that concludes my remarks on computer power management. I'll check in with Lynn real quick here and to see if there are any questions pertaining to power management that I could answer, and if not, I'll just continue on.
Hi, Mike. Nobody's typed any in, but I actually had one. You commented that generally when an organization, as opposed to a human being, bought something, a computer, like directly from Dell or Hewlett-Packard, that the power management settings, the Energy Star settings, were not enabled. And that surprised me. I used to think that was true, and then I had heard that when you bought EPEAT qualified equipment, that in fact it was delivered enabled because that's a requirement of EPEAT. So now I am confused.
Well, I've succeeded in confusing you. You're absolutely right. We didn't get into EPEAT, but if you do purchase an EPEAT qualified computer, their requirements stipulate that these settings have to be enabled. So you will not have to worry about manually activating these settings except for the following situation. A lot of times the person who orders the PCs may not be the same person that's deploying those PCs. And I see this all the time. They'll actually disable those settings that come from the manufacturer, and it has to do with the way that you deploy new computers in a large organization. So it's not at all uncommon for, even though you purchased EPEAT, for an organization to override those settings when they deploy the new computers. It has to do with the way that hard drives are replicated when you roll out a whole bunch of new computers. And we can get into the detail in the Q&A. So the answer is you're probably okay if you purchase from EPEAT, but you got to check.
Okay. And so a question has come in. What about computer power management settings on file servers? We are told that servers should not be turned off and do not have the same type of energy-saving settings.
That's absolutely true. And we're going to get into kind of this. We're going to do a surface scan of energy savings with servers and data centers. But because of the way the nature of how servers are deployed, they do have, in many cases, particularly newer servers, have built-in features to save energy. Sleep is still in its infancy for servers for a variety of reasons. So yeah, that's true. You don't want those servers at this point going into sleep mode when they're inactive. That what they should do, if you've purchased an energy-efficient server, is they should drop to a pretty low-powered idle state, but still be available for remote access.
So is that something you'd have to configure yourself, or that's just if you bought the right one, it's going to do it?
Yeah, you know what? I have a slide on this, so we'll get into
never
it.
Mind then.
In fact, it might be. You know what? It might be. Yeah, it's coming right up.
Okay, thanks.
You bet. So let's talk about ENERGY STAR qualified equipment. I think most of the folks on this call probably know that, you know, if you're going to buy new computers, they should think about an ENERGY STAR qualified model. But you may not realize that you have an option if you're purchasing a water cooler, or if you're leasing or purchasing vending machines, or TVs, or DVD players, or and this product in the, a little hard to tell, in the upper left is a computer server. So it's important to understand the full range of ENERGY STAR office equipment, and if you have purchasing protocols, that you mention ENERGY STAR in those protocols. And then, of course, there are a lot of products that will be listed soon that you have not had an ENERGY STAR option for previously, and that's things like Wi-Fi access points, small networking equipment, and I'll talk about a few more in a minute when we get into the data center. So this gets at your question, Lynn, and it was about, you know, do I have to do anything with those new servers to take advantage of the power consumption savings, their efficiency features? And the answer, fortunately, is no. You know, initially at least, simply by plugging in a newer server that's ENERGY STAR, you can expect to consume about half the power of a 3 to 4 year old server and get a lot more processing power in the bargain. And if you actually actively use some of the features that are available with the server software in your organization, you may be able to do even better than that. So the answer to Lynn's question is, just by buying a more energy efficient server, you're going to get pretty nice energy savings. And then you'll also get access to features that can be utilized to save even more. They're a little beyond the scope of this presentation. So servers, vending machines are huge energy hogs for a variety of reasons, and I like to mention them because some organizations actually have quite a few vending machines. Not many organizations actually own them. They have an arrangement with a service provider. So what I want to tell you is, even if you don't purchase vending machines, you should request from your service provider that they provide you with either ENERGY STAR qualified vending machines, or machines that can take an ENERGY STAR retrofit kit, or use what's called a vending miser device. And those are 3 ways that you can dramatically cut the energy consumed by vending machines. So we're going to talk next about computer peripherals and plug load, and we'll spend a few minutes on this, and then we'll get into data centers. I think my favorite way to save energy is the Smart Power Strip. I'm sure all of you have favorite ways to save energy, but this is why this is mine. What I've got pictured here is one of 3 flavors of Smart Power Strips. And it's called a current sensing Smart Power Strip. And the way this works is you can plug your monitor, your computer monitor, which generally has a separate power switch, a power outlet rather, into the master switch. Then what happens is, when that monitor goes into sleep mode, and let's say you actually followed EPA's recommendations and that monitor goes into sleep mode after 5 minutes or 20 minutes, it will trigger all of the items that are plugged into the switched outlets to the right to actually turn off. So when your monitor goes to sleep, your task light can turn off, your printer, scanner can turn off, PC speakers, backup drives. You're not supposed to have space heaters, but if you do, they can turn off, fans, etc. So this can be a big savings if you have a lot of things plugged around a workspace. I actually don't recommend that you plug the computer into one of those switched outlets for a variety of reasons we can get into. But generally the safest thing to do is have that computer have power available to it at all times, but drop into that low power sleep mode when it's inactive. I also say, put your phone charger there too, because we've done a lot of work with Energy Star and phone manufacturers, and the net of it is that phone chargers are incredibly efficient now. And even if you did unplug your phone charger every time you were done using it, you might save 50 cents over the course of a year. So it's just not going to save you much.
Mike, this is Lynn. So in reality, here's what's been happening during this webinar on my laptop, which is where I am seated. My monitor is set to about a 5-minute power blackout. And so every few minutes, I'm having to tap the screen, and it comes back. If I did what you're describing, then everything else in my life would be going off.
That's right, and you may call me very angry. So it's a great point, Lynn. And what we recommend is you have to listen to your users and find like the right mix. And it may be that those task lights should not turn off, when your monitor goes to sleep. Or it may be that you want to switch your monitor to sleep after 30 minutes rather than 20 minutes to take into consideration what you just described. There are two other, I mentioned there are 3 flavors of these devices. The 2 other ones might be a better application for a situation like yours. And one is, one has a built-in timer. And the way you'd use that is you would have, and it's a digital timer, you can tell all the switch outlets to turn off at 6 p.m. and turn back on at 9 a.m. or something. And the other flavor, it has an occupancy sensor on it. So it knows if you're sitting at your desk, unless you're incredibly still, it will know that you're there, and it will keep all of your lights and fans and whatever on. So in some cases, those work better for you. This is one of those things where before you go out and buy a bunch of these, and average retail price of these devices, $20 to $40, depending on bells and whistles. But your utility may offer discounts and rebates, so you want to approach them first. Second major tip for reducing plug load energy consumption has to do with your printers. And it's essentially reducing the total number of printing devices in your organization. We went through this period 10 years ago where everybody needed their own printer in their own office or in their cube, and now, of course, networking technologies come a long ways, and that's just really unnecessary. So consolidating printers is exactly that. You're going to go around and pull out of the organization those older, higher-cost printers. You're going to share networked printers, multifunction devices, etc. And you, of course, will save electricity, but you'll also reduce expenditures on new hardware, maintenance, and, of course, paper, ink, and toner, because you don't have to supply nearly as many machines. And most organizations now go to, in a typical commercial setting, it'll vary, but, one shared networked multifunction device for every 10 to 20 users. Savings here, if you added up what you spend on printing in a given year, you might expect to save as much as half of that or more. And of course, that's not just energy savings, that includes the hardware savings, maintenance savings, etc. And that brings us to data centers, which, as I mentioned, is a big meaty.
Mike, can I interrupt you again?
Absolutely.
Okay. So I'm intrigued by that last printer slide or combo thingy. So the State Electronics Challenge this year expanded, as you know, to include imaging equipment, which this object would be. And so I'm curious about what you might know about the power management settings on these combination devices, and I know there are now EPEAT qualified devices like this, and whether those come automatically enabled. And then a perhaps more esoteric question is, do you happen to know what the energy saving is for, or if there is, for using it as a scanner versus a printer or copier?
Ooh, good question. You're stumping me on the last one. I don't know.
I figured. I never even thought about that before, but
Yeah, I don't know. I mean, they both are, they use a high-intensity light bulb in most cases, in both cases, rather. So it's a good question. I don't know the answer to that. But I do have good news with regard to your first question, and that is that it used to be that these settings were not defaulted on copiers and multifunction devices. And it's almost hard to find devices now that don't have those settings enabled. But a lot of times you can improve on them. Like if you know certain times of day that just nobody is going to be there, and you can have your machine completely switch off, in many units that's configurable now. The other bit of good news is it used to be a complete headache to try to find the user's manual and get to the bottom of how to configure these devices. Today, most devices have a pretty good user interface that, if you spend a few minutes, you could figure it out. But even better, all you have to do is Google the model number in the make and power management settings, and you will pull up from dozens of different sources instructions for that exact model on how to take full advantage of the sleep settings. So even if those manuals are long gone, the information exists, and you'll be able to take full advantage of those settings. And we work with a lot of large organizations. Is this a giant energy savings opportunity to make sure that those sleep settings on printers and copiers are, fine-tuned? No, but it's a great project for a summer intern, or something like that to go around and check, especially if you have a lot of these devices in your organization. So data centers. So before we talk about how to save energy in a data center, I think we need to answer the question, why are data centers such energy hogs? So I'm going to give you a real-world example. We worked with Industrial Light and Magic, they're a special effects studio based in California, to deploy a bunch of new servers. They used a pretty energy-intensive type of server. They're called a blade server. You can cram a lot of these into a server rack, which I'll show you what that is in a second here. Just one rack of those servers uses 28,000 watts of power, and it requires 8 tons of cooling per rack to cool the waste heat that is generated by computer processors. So just for giggles, we compared this to something that maybe most of us are a little more familiar with, and we came up with the following calculation. We think that the heat generated by these servers is roughly equivalent to about 4 Weber gas grills. So if you can, picture a server rack with 4 Weber gas grills going full blast, and you begin to appreciate the amount of heat that's generated. And this is just waste heat by this equipment. And know that you could cook about 300 burgers per hour with this amount of heat. So data center energy savings, 3 areas of opportunity. One is the IT equipment itself should be as energy efficient as possible, and there are a whole host of ways to ensure that. The second big, and these are kind of the 3 buckets I like to think of the energy savings in a data center to sort of keep this manageable in your mind. One, make sure the IT equipment is efficient. Second, airflow management. What's that about? Well, given all the heat that I just described, the big job in a data center is to remove that excess heat efficiently. So airflow management is all about delivering cold, cooling air to those servers so they don't overheat as efficiently as possible, and exhausting the hot exhaust air that comes out of the back of the server as efficiently as possible, and ensuring that those 2 streams of air mix as little as possible. So that's the airflow management bucket. There's a bunch of things you can do in airflow management to make things more efficient. And then the last but not least, HVAC adjustments, heating, ventilation, and air conditioning. These are things like making sure that the type of AC unit that you use is efficient, that the temperatures are set appropriately, that the humidity is set appropriately, a whole host of things. We've done a lot of work in this area, and what you'll see on this slide are sort of the top 12 ways to save energy that come up in most data centers. And these are kind of roughly broken down by those 3 categories. The first 5 have to do with making sure that the IT equipment itself is as energy efficient as possible. Then number 6, number 7, and number 8, number 9 have to do with airflow management. And 10, 11, and 12 have to do with HVAC efficiency. And as I mentioned earlier, we do an hour-long webinar where we just go into a little more detail on each of these. It's still for non-technical audiences, and I'll talk to Lynn if that's of interest if you happen to do it. But know that you can go to this website, energystar.gov/low-carbon-IT, and you can read a couple of pages of information about each one of these opportunities. You'll get non-technical descriptions of them, impartial information about how much it would cost perhaps to deploy this, savings, things you have to consider before you dive in, those sorts of things. So I'm going to conclude with the actual energy efficiency measures now, and I'm going to talk for a few minutes about how you get action, kind of going in your organization. Because it's somebody who is non-technical, this can be a tough thing to get rolling in your organization. So this is what I recommend. And the first thing is to do a little bit of a walkthrough in your organization and look for some of the savings opportunities that we've discussed today. If you're doing a data center, you may not have enough information until you go to the website I just showed you. But for computers, it's fairly simple. Walk around one night and see, are computers still active? Are you seeing flying toasters or whatnot on the monitors? Are the computers still humming underneath the table? In general, do people tend to leave their computers on at night? How many total computers? And you could take this information, as little or as much as you have, and enter it into a savings calculator, that same website I showed you, and get a back-of-the-envelope estimate of what it means to power manage in terms of savings for your organization. And then you can take the opportunity up with your IT colleagues, and if they counter with some technical jargon, your answer is easy. Hey, you might be right. Why don't we get a vendor-neutral tech expert on the phone and hash it out with them? And what you can do is schedule a free call with one of my engineers, and they'll walk them through the answers to any questions or concerns that they have from a technical perspective. You'll want to estimate the savings based on their feedback that you might be able to achieve from either computer power management or any of these other projects. And like I said, there's a savings calculator here for computer power management. There are other savings calculators elsewhere for some of these other things. If you're interested, I can pull together a resource for you. You want to talk to your utility because they have incentive programs sometimes for computer power management, for a whole host of data center energy efficiency measures, for the smart power strips, and a whole lot of things we haven't talked about. But the trick with utility incentives is if you've started your implementation of any of these measures, it's too late to get their funding. So you want to talk to them earlier. For computer power management, reliability and security are side benefits of a whole host of energy efficiency measures. So it's not just about saving energy for your IT staff, and those are some things that we can help them understand as side benefits. And of course, build a coalition for change, share these opportunities with friends in finance and facilities if your IT department isn't fighting initially. It's worth spending a minute talking about why some projects don't go anywhere with IT energy efficiency. And it reminds me a little bit of this old Far Side cartoon. So what often happens after a presentation like this is if you stayed awake, you may leave the presentation and go have a conversation with your IT person. Hey, heard about computer power management, data center, energy efficiency. Why don't we do this? And what you hear back will be potentially very detailed technology information that is absolutely indecipherable. And this happens every day. So, what do you do about that? And my answer is the key is this second step. It's, hey, good question. Why don't we get a vendor-neutral technical person on the call? It doesn't cost us anything. And what happens is we kind of get them past their concerns and questions, but we also save the IT staff a ton of time because, without our help, they'll have to research a whole host of, potential solutions or test a bunch of different potential solutions. We've done it all, so we can help them save an enormous amount of time. So bottom line is you really need an IT expert on your team to keep things on the rails, and now you have one from our team. So here's a quick reminder of some of the freebies that you can take advantage of with us. I'm going to keep my contact information up here while we take some questions. The link that I mentioned where you can find all these resources is at the top, EnergyStar.gov/low-carbon-IT. Again, I'm Mike Walker. This is my contact information. If you're interested in reaching Steve Ryan, he is my client. He runs the Energy Star program, all of Energy Star's low-carbon IT programs, and I've given you his contact information here as well. So let's leave it there, and Lynn, I'd be happy to entertain any questions at this point.
Great. Mike, thank you so very much. I know that I personally learned a great deal, and I loved that hamburger calculation. We may have to add that to our annual sustainability reports. We're going to get the greenhouse gas equivalents of energy savings. We're talking hamburger equivalents.
Assuming you don't have any vegans on the
well, we might
board.
have to add that to the survey. Well, it could be tempeh burgers, couldn't it?
Absolutely.
Something of the sort. So thank you so much. We do not currently have any more questions, although we certainly welcome them from anybody on the call. Just start typing, and I'll see them. Unfortunately, somebody had to leave the call. He sent me a little note about it. But this is somebody that I know has, he's been his agency has been a State Electronics Challenge partner for many years. And every year, they come to us with approximately a similar question, which is that they try to buy ePeat, but then when they go to their procurement people, they're told that the specific configurations that are needed for their agency undo the opportunity to have ePeat qualifications. And every year, it turns out this is an Energy Star problem and not an ePeat problem. And we go around in circles, and we're always sort of frustrated that Energy Star isn't tackling the nuance. And I have to apologize because I don't know the nuance, but I'm wondering if there is some way to engage Energy Star in this conversation more specifically when it comes up again this fall.
Yeah, I would be happy to be a conduit for that conversation. Yeah, and I'd also be very interested in understanding the details.
Right, as opposed to what I just said? Uh-huh.
Yeah. I was not implying that you didn't have all of the facts at your fingertips.
I know it's a problem. I know it's not ePeat. I know it's Energy Star.
Right.
And I guess you're not actually psychic. Okay.
Please use me as a resource, though. I'd be happy to try to understand, what the issue is. I mean, the bottom line is we do encounter these things.
Yeah.
The vast majority of the times, that the limitation that the IT staff is worried about, there's a workaround.
Okay.
The vast
great.
majority of the time.
We'll definitely follow around with that. So here is a horrible comment from somebody who I admire greatly. My computer's system standby setting has never selected. What do you recommend?
Is not selected, or
No, it has the option labeled never.
Okay.
When should my computer go into standby? Never.
Yeah. The answer is when you're conducting a presentation like the one I'm doing right now. That's when it should never go into sleep mode. And the good news there is if you're a PC user and you use PowerPoint, Microsoft PowerPoint, all of the recent versions of Microsoft PowerPoint actually know, they're smart enough to know that if you're giving a presentation like I am right now, the screen should not go into sleep mode.
So you could have, so he could have he could change that setting to, let's see, he said it was his computer. So is that that wasn't the 5-minute one, that was more like 15 to 20 minutes? Change it from never to 15 to 20 minutes and he'd be okay?
With the following caveat, you want to talk to your IT administrator first. So if you're in a small organization where you don't even have, a dedicated IT person, maybe it's a home office or maybe it's a, very small organization, absolutely go ahead and make that change. The good news is even if you have programs that need to run, in the background, maybe it's a backup, for instance, if you kick off the backup before you leave in the evening, generally the processor will stay active enough running that backup that the PC won't sleep. So in the vast majority
of the process, that will itself prevent it from sleeping.
That's right. There's enough processor activity that the machine won't go into sleep mode. So generally speaking, absolutely change that setting unless you have a centrally managed IT department. So in other words, either a contractor or a staff, employee staff manages those security updates and other things on your computer, maybe manages the software. So, the quick test is, do you have an IT person you can call? If so, then you need to consult them first. And here's why. It may be that if you have your computer going into sleep mode at night, you may miss some of those security patches or the backups or the antivirus updates that you need because they are currently pushed out at night over the network. So you just need to confirm with them whether or not it's okay. If you're going to have that conversation, what you really want to ask is, hey, I noticed that my machine is configured to never go into sleep mode. Can we change this as a policy for the whole organization? And then you can take us up on the offer to join you for a conference call to answer any questions.
And that circles back to the how do you bring people into this conversation.
Exactly.
Right.
Exactly.
Great. Great. Thanks. Now, do you happen to have any data that you can share about the difference in energy consumption from a CRT type TV or monitor versus a newer Energy Star flat screen LED?
Yes. Just real quick, and it depends on the size and the age of the equipment, but generally speaking, a CRT monitor will burn at least 50 to 60 watts of power if it's fairly small, and it can go up to a couple hundred watts if it's a large CRT monitor. We don't see a lot of those anymore, but they're still out there. They never die, so they're still out there. Then the LCDs, in contrast, can use as little as 15 to 20 watts of power for like a laptop display. Most external displays are getting near 25 watts of power or up, depending on how big they are.
Is that true no matter whether we're talking about a television or a computer?
There can be differences because the requirements that Energy Star has are different for TVs and monitors. And the quick answer is if it has the Energy Star label, it's probably pretty energy efficient. And to put a finer point on it, I don't even know if anybody's making CRT TVs anymore.
Well, they're not so much, but they're certainly out there in homes. And when you're talking to your public as a regulator and trying to encourage them about why it would be great to get rid of these things, the conversation about the impact on energy costs and conservation, I think, is something that perhaps state agencies would be interested in having in their arsenal.
Yeah, so there are, to answer your specific question about the data, rather than just general ballparks, yeah, actually on the Energy Star website, there's some links to some surveys. I'd be happy to dig those up for you because that website can be tough to navigate. But
that would be great.
Yeah, some survey data on the power consumption for different models of monitors.
I would very much appreciate that, and then I can share it with the folks on the call who might be interested in that. That would be wonderful.
Sure.
Well, Mike, I just want to thank you so incredibly much. As always, this has been hugely informative and reassuring also that we can, in fact, make these changes. So certainly anybody, if you have, as I said at the beginning of before Mike started his presentation, if you have additional questions that occur to you after this conversation and you'd like to get in touch with either Mike or myself, don't hesitate. If you want to be reaching out to have these conversations within your organization, you'll be able to contact either Mike or the fellow from EPA that he referenced in the slide that I no longer am looking at. As I said also earlier, we are going to be posting the PowerPoint itself on the SEC website, as well as, if everything went according to plan, the recording. So I'd like to again thank Mike so very much, as well as the EPA Great Lakes Restoration Initiative, and Samsung, Panasonic, Sims Recycling Solutions, the Consumer Electronics Association, and the R2 Rios program, and to the State Electronics Challenge partners who are on today's call. So thank you, everybody, and we'll say goodbye now. Bye-bye.